vi får stuva om. Pelle sprang ut igen och jagade talare. Och så kastade han in mig i det här. Och vi har beslutat att byta plats på de här två punkterna på slutet av dagen. Så att I will now welcome Peter Burry from VMware to talk about the VMware new NSX concepts. Welcome to KTH, one of the universities in Stockholm.
Yeah, well, I had an interesting experience with a taxi driver earlier on. Is that better? Is that coming through? Okay, sorry, I'm just booming along, so that's a little bit better. I won't repeat the last 5 minutes, by the way. But if we were to look at, the old way that people did security, you'd start off, you've got the soft internals of the network. That's absolutely great, whether it's all the databases, the applications, etc. You've got a perimeter network, which has some kind of access into it. Think of a DMZ, depending on your accent. And you've got the border network, which is when you're getting more to the service provider. You've got the router, the switch, etc. Now, this is done really, really nicely for a long time for many people. The problem is, though, that as you start to scale it up, you've got an application running. I'm going to show you an example which is taken from one of our customers, who's actually an airline company. And they, started off with this kind of idea, a nicely segmented physical firewalls. And then their whole service offerings, everything they were trying to do just went boom, okay? Especially when the whole idea of cloud and things like that came up. So as they scaled this up, what worked for a single instance of an application suddenly became something like this. This is intentionally a horrible diagram, by the way. The idea being that, we've got all these things like premier customer things, we've got car rental, we've got all these different services that they're trying to offer. They've got kiosks, all of these things. And they're trying to build it in around what was, an architecture they put together, well, when people started doing this stuff. And as you can see, it's got to a point where sitting in the middle, you've got this one poor firewall that it's the ingress-egress point for just about every service they're running. It's got a rule base that you wouldn't believe. I think there's something in the region of 5,000 rules on the example that we're taking. And the worst bit is that nobody dares to touch it. Now, if anybody's dealt with firewalls, and that's what I did for a long time, one of the funniest things we used to do for customers was a firewall audit, which is to check the rule base. Now, very often, firewall audit means, can you just help us understand our firewall? Which is kind of it's a chicken and egg kind of question, because I can tell you what it says, but I don't have the full context around it, what you're doing. Anyway, so this is kind of the situation they ended up with. This poor old firewall, it's got things tromboning in and out. It's got, services that maybe don't exist anymore, but it's so important that they're really, really, really not willing to touch it. One of the funny things with this customer is they actually went for an internal audit, not against any kind of external or commercial or whatever standards, but their own audit, and they failed it, because they just couldn't actually work out what this is all doing together in the context of all of these different services they were trying to provide to the customers. So it kind of goes back to this particular picture, that if you've got an application, and I did say I'd start old school, don't worry, I'm going to get into the new school stuff, as it were. Couple of concepts there. We're going to talk about north-south routing, which is internal-external. And we're going to talk about east-west routing, which is essentially along the applications, along the servers and the stack. So great, an ideal, simple world where an application is a single server and people talk to it from the outside. You've got this north-south traffic that says, great, people go from their laptop, whatever, to the server, through that firewall, everyone's happy. The problem is, it's not really a single instance. Probably the most simple example people give is web server, application server, database server for a three-tier architecture. Well, that's great. So you've got this potential that as well as that north-south traffic, you've got a whole load of east-west traffic going on as well. So user comes in, absolutely great. They're going to talk to the web server talks to the application server, talks to the database server, talks to the content server, talks to the enterprise services device, etc. And suddenly, you end up with this absolutely huge amount of east-west traffic. Now, I don't know if this looks like a familiar concept or something you see in your own architectures, etc. But there's one other really big problem with this, and this partly is a problem in the physical world, but we see it a lot when people start virtualizing things, which is simply, yes, you've got this traffic moving along, excuse me, get my animation. But to actually segment all of these different services are sitting off that firewall in different little pods of security, different secure zones. So rather than just going into a flat network and saying, let's talk along there, what do you think happens? Well, quite simply, when the web server wants to talk to the app server, it actually goes back to that firewall and says, could you see whether or not I'm allowed to? Just trying to think if the animation actually reflects that properly. Okay, oops, there we go. So you've got this potential, there's one best practice that says, these firewalls shouldn't actually be doing any kind of dynamic routing. So you've got static routing tables governing how these systems can talk to each other. And you end up with a big problem, which is called tromboning, which is the traffic coming in to the web server, goes back out to the firewall, to the app server, out to the database server, out to the and you end up with this absolute horrible mess, because you're looking at a single point of enforcement, and you're looking at a model that says, here is my perimeter, and I'm just working out based on that perimeter where things can go. Now, this gets a little bit philosophical at this point. There we go. Sorry, my animation is, fingers crossed these things can work. What you're really talking about here is a concept around inherited trust, okay? So you've got what you use, whether it's the corporate laptop, authorized intelligent phones, whether you're on the internal network. And you're also basing your security on where you work from, okay? So pretty standard stuff, access control lists, routing, etc. Based on that, what you use, where you work from, you've got access to all the different services. Now, obviously, I'm using some pretty standard examples like Exchange. I've got Oracle in there, etc., etc. This is actually quite a common thing that we find with universities, especially where they've got research fellows who need access into systems. So, there's actually a different model. Has anybody heard this expression before, zero trust? Okay. The idea being, really, with zero trust, the problem you've got is that the perimeter isn't flexible enough for all of these different services and all these different users on the outside, for meeting at the outside and the inside. Okay? There is actually a piece of Forrester research just referenced up there about this model. The idea being that rather than having this massive segmentation, you look at the point where users can access the network on any device. Great. But how about we're a little more intelligent and not all users can access all services? So we're moving away from internal and external hard perimeters to something that's slightly more intelligent. You know, in this case, we're focusing on the application and the data rather than the network and those devices. So what does it require? It requires you segment resources based on their usage. It requires access monitoring, need-to-know basis, and you know, verify and never trust or inspect log traffic. The model itself, the idea is it enables mobility, and it's really one of the steps about how you get into cloud computing without compromising security badly, because a lot of people have got to the point where they virtualize stuff, and obviously, you know, VMware, hands up, we do lots of virtualization. But as soon as you go to this, well, I want to be a little more dynamic about that. How do I actually make it into reality? So we'll bring up a slightly less scary diagram. So what we've got here in the green there, you know, are the external users, any device, etc. Now, what we then have is a perimeter device. That's the firewall. I'm sorry, I don't actually have a pointer on here to actually demonstrate this. It's readable anyway. And behind that firewall, we then have kind of the first point services that people need to get to, whether it's F5 load balancing, whether it's WebSense, whatever it may be, those particular services, authentication, proxies, however. And one of the principles here is that rather than having this very segmented network on a physical RJ45, whatever it may be, kind of level, what we're trying to set up now is they are zones of trust, but they're basically containers that define who can talk to what, who can talk to something once they're in there. So if we take the example of somebody talking to Exchange. Now, in the old world, a user says that's absolutely great. I'm going to talk, you know, to the CAS, the client access server. This just gives a little bit of an example of all the moving bits and pieces and all the parts that make up an instance of Exchange. And in the old world, as it were, maybe you're going to have all those different components in their own security groups, own subnets, whatever they may be. They're going to be segmented off from each other. There's going to be firewalling in place so that each individual component can only talk to the next one in line. So where each of those arrows exist, and you'll see we've got the various port numbers, you're going to have some kind of segmentation. Absolutely great. Now, what we'd really start to say in something more like a zero trust model is that we're going to have somebody going in, and I'll try to talk through this a little bit. There we go, that's better. Once they've got to the F5 device, well, absolutely fine, that's just the example we're using for getting through. We're going to put a wrapper all the way around the Exchange device that says a person can go in. They're then forwarded onto the Exchange device, client access server. It's in its own little bubble that defines who can get in, who can't. And additionally, when it comes to authentication, you'll see there's an arrow going across to Active Directory servers. So in that particular case, there'd be a bubble around Exchange, there'd be a bubble around Active Directory. There's also a bubble around the different sort of greater containers as well. So in this case, rather than micro-segmenting all the Exchange, we're putting it in the security container, defining who can get in, who can get out. And each instance of Exchange, we're doing this. One of the big concerns people have when you start talking about a more broken down model like this is simply that, well, what about somebody getting in, compromising a system, and then leapfrogging over to the AD servers? Well, the idea here, we're still using access controls, is that even if somebody does get in, the access controls are not sufficient if they're actually in that first pink zone, app gateways, not sufficient for them to actually leapfrog directly into Active Directory. Another example comes in, well, what about the actual management of this? Again, we're trying to look at a straightforward idea that somebody goes in, they go into a management, that's, as we call it, the admin jump point, which then have the required access. Now, what we do in a VMware model is we give people a virtual desktop because it's essentially much more difficult to compromise, infect, etc. Somebody who's, IIS administrator logs in, they get provisioned an IIS They can provision an IIS desktop, etc. Once they've finished, it's torn down. So first point there is looking at these various zones of trust that we're trying to put together. Okay, there's the administrator. Now, we thought we'd put a big, beautiful, powerful graphic up here. I don't know, I was having a strange day yesterday when I was looking for a graphic because I'm bored of the company colours, and I just thought I'd have I don't know, something from Dungeons and Dragons. So people say, okay, we've got this idea where we're going to be essentially flattening out what we do from a networking and a security perspective. But we don't want to get rid of, we don't want to be in any doubt that security is in place. When we also want to make this manageable because we've got this big worry that by introducing virtualization technologies, we're adding complexity, we're adding stuff that we don't understand, and it's going to be even harder to manage. Now, that's where NSX comes in. Go through a few ideas. One thing I'm going to talk about briefly in this is the difference between software-defined networking and network virtualization. Sorry, sounds like a lot of buzz terms. The core idea behind NSX is that, think back to that example where you've maybe got racks and racks and racks of virtual equipment. And you've got traffic coming in, hitting a device, tromboning out to that perimeter firewall, tromboning back in, etc. What we're talking about is moving a lot of the networking complexity and moving the security actually into software. And by into software, I mean into the hypervisor. In our case, it's ESXi. Of course, there are lots of people, I don't know, maybe you guys use things like Zen Server, KVM, things like this. If there are any people here who are particularly keen on using Linux as a virtualization platform, the technology I'm talking about here actually had its birth and actually had its development under Zen Server and KVM deployments, and it's when we made a bit of a purchase that it came over to running on ESXi as well. So it's actually based in that background. So the idea is that I can take all of these networks, all these routers, etc., and instead of running them on these physical switches, firewalls, routers, routing devices, whatever, I can do that described in software, and I can do it across any physical hardware. If you think back to the idea of what virtualization at its most basic is, at least for us, is to virtualize compute, so CPU, RAM, that kind of thing. All you need is x86. That's it. That's the basic bedrock, the foundation. To virtualize networks, all you need is an underlying IP transport. That's it, kind of thing. Because all of the intelligence, we're moving up a level. So, there you go. On top of the network hardware, we create virtual networks. Now, I've always got to be careful what I say here, because I've got a badge that says VMware, but one of the things that we are quite particular about is that we want this to run on any hypervisor, whether it's Hyper-V, yep, I mentioned Microsoft, whether it's KVM, whether it's Zen, whoever it may be, we want it to run on those particular platforms. And once you've got the hypervisor running, this is the bit where the network virtualization lives. So it's not living down on the hardware anymore. You start getting into concepts here, I'll just read off, like creating logical layer 2 and layer 3 networks, logical VPNs, load balancers, firewalls, etc. So in that stack, you've got the basic foundation, which is the layer 2 and the layer 3 networks, done in software. And then as part of that, sitting on top of it, you've also got the actual virtualized, the software-defined security. Okay? Now, the idea then is that once this is done, you can run any application on top of it. A few of the ideas that we like to talk about in our particular variation of this is that automation is a big point, and I'm going to come into things like cloud management platforms and a few other bits and pieces in a second. When people look at this, their first thought is, well, this is great, but that whole thing of reconfiguring the networking, reconfiguring the security, all I've done is move that problem up a level. I've moved it from the hardware, the actual Juniper, Cisco, Arista, whatever it may be equipment, and moved it into ESX. Well, what we're really looking at, first of all, is automation. And we do take a very, very heavily API-driven approach to this. So rather than saying, I'm going to create networks manually, roll the sleeves up every time, how about you actually define them as templates, just like you do the compute? And whenever somebody says, I want to provision one of these things, it's a click of a button, and from the cloud management system, whatever it may be, it's driven through an API system. Okay. Within our lingo, our terminology, we're using something called Service Composer, which is how we add the security onto it. We've got server access monitoring, and also one of the big fears for security people is actually the monitoring that we do. There's traditionally been one of the biggest pieces of resistance to doing this, and this has been going quite a while before we had anything to do with it, is that there's an idea that when I actually send traffic into a virtual system, if I'm a networking guy, the second that traffic hits the network card of the hypervisor, it's invisible to me, it's gone. And that has often been the biggest objection. But what we're talking about is building in the monitoring tools, whether it's NetFlow, whatever it may be, in such a way that you have the same visibility with the same tools. We're also talking there about the rich networking. So one of the big things there is scalability. Okay, so we've got some ideas, creating these logical switches, mapping physical to virtual, doing dynamic routing. If anybody's ever looked at the old style VMware networking, which is something we call VCNS, vCloud Networking Security, one of its biggest limitations is it only supported static routing. So again, sleeves up, create the routing tables. Obviously, it's absolutely essential in this case that you support. You can talk to the outside world, BGP, OSPF, etc., etc. Other parts here as well, partner extensibility. Rather than reading through that, if I was to say what VMware does as a business, it would be, we're an infrastructure company, I suppose. We provide infrastructure that you virtualize onto. What we are not is a security company, which may sound strange, me with a VMware badge talking about security. We don't do intrusion prevention. We don't do antivirus, data loss prevention. We don't do, network services like WAN optimization or, or the F5 kind of thing. So it's very important that all of this stuff you can actually plug third parties into. For years, we've had something called Endpoint, which allows the insertion of antivirus through software, etc. We're now talking about the networking side. Okay. That's kind of the high level. We're going to go step by step into how this works. One of the components, and it gets into this whole bit about software-defined networking and something we call network function virtualization. And I'll try and make this as straightforward as possible. Has anybody ever read any of the white papers that Google produced that describes how they run the networking in their data center? I don't know. Okay, oh, excellent. Has anybody looked at the original definitions of software-defined networking? Now, I actually, whenever I talk to people who are looking at doing this, I carefully avoid the word SDN because they get this instant image of what you've read about, which is, in the case of Google, using something like OpenStack and OpenFlow to control the existing physical switches and routers. So when something new happens, I actually programmatically reconfigure the underlying network hardware. And that is absolutely brilliant. That is software-defined networking, or a definition of it. One of the guys we have who basically wrote this stuff, Martin, he's kind of credited with coming up with the phrase SDN. I think he had it suggested to him. And if you talk to him now, he actually says he has no idea what it means anymore because there are so many different variations. What I want to be absolutely clear about is we are not doing this, okay? So have we got a definition there? Yep. We're taking a few of the principles, but we're not controlling the Cisco kit, the Juniper kit, the Arista kit, the Brocade kit, whatever it may be. We're doing all of the complex stuff in the hypervisor, in software, okay? And one of the central concepts in software-defined networking is separating the data plane, as we've got there, from the control plane. For the control plane, think of a control module. For the data plane, think of a line card, something like this. So while we actually do have the hypervisor sitting on top of the physical network, and we have virtual switches, virtual routers, virtual firewalls, etc., 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 above that, we've got this control layer. Because there's got to be some way that all these different moving parts know about each other. There's got to be some kind of communication. There's got to be some central brain that can run all of this. And that's where the control plane comes in. It also deals with things like, dynamic routing, etc., updating routing tables. But that's a very central concept that the control is absolutely separate from the data. Now, there you go, centrally managed, programmatically configured. The model that we use says, great, You've got the line card equivalent. You've got the control plane, which is where the brain lives. At the top, you've got the management, the application plane. This is not from an application as in web services, etc., or databases. This is the point where you as a network administrator connect into this system. Now, I'll break this down a little bit in the next sort of explanation as we go one step deeper. But if you're familiar with vCenter, I guess, which is dealing with all the compute, well, we're adding in the NSX controller, and while you have a compute and a networking component, above that, you really want to start looking at what's actually going to orchestrate and automate all of these different things. And I am aware that using orchestration and automation in the same sentence can be dangerous because they actually mean quite different things. One of the ideas here being at least that a lot of people will get very, and I'm talking some quite big organizations, they'll get very hung up on the minute details of how they're going to virtualize the storage, virtualize compute, virtualize the network, because it's inherently cool stuff and technical people love this. The argument we kind of give is that it's nice to know what the options are, but before you decide what the networking should be, before you decide any of the, how you're going to do the compute, you really should actually decide on what your cloud management platform will be. Because what do you define in the cloud management platform? You define the service catalog. And what is the service catalog? Well, it's actually the answer to the questions that your business wants to answer. What service do we want to provide to users? What service do we want to provide to, in this case, other educational, academic institutions? So work out what you want to do, work out how you're going to do it, and then start drilling down into this stuff. Okay. So that kind of gets us away from software-defined networking, going into the switches themselves, and goes into network function virtualization, which is running all of this stuff in software. Got a bit of a definition there. Network functions in software. They run today on dedicated hardware. Standard server and IT virtualization. We're looking at multi-versioning, multi-tenancy, applicable to any data plane. Automation of all that management and configuration. Now, very often when people talk about NSX, we'll talk almost exclusively around this concept, which is having intelligence built into the controllers. They're actually keeping all of the guys doing the routing and the switching in order, and then having this management plane where you can do the config and the automation. But one of the questions would be, how does this actually work? Here's a little diagram to give you an idea. So what we've got here are a pair of hypervisors. We're trying to be agnostic, but just let's say vSphere hypervisors. We've also got the NSX controller. And on those hypervisors, they're connected to the routing network, and they've got what is essentially like a gateway, a couple of different IP addresses in the 10-dot network. Now, to perform network virtualization, that little component we've got there, the blue one that looks, with all the arrows, looking a bit like a switch, what we're doing here is we have a gateway component. It's a layer 2 gateway, which is called a VTEP, VTEP, which stands for VXLAN Termination Endpoint, which is a big, kind of impressive name. The idea being that this is a component that we can use to isolate the compute virtualization from the physical network. So we just build this up a little bit. Okay. We're going to abstract that away a little bit, and all the routers and switches just say that's the IP transport that you need. We're not actually too worried at this point about how things exist underneath. We've got these IP address ranges, could be a bit of a problem. Okay. We've also got the cloud management, which is, in our case, a combination of vCenter and NSX manager. Talk to the control cluster, talk to the compute. Now, it's great. So we've got these two clusters, but what we'd actually like to do is be a little bit more imaginative. We want to create, and in this example, that's a logical description of the network we want to create. So somehow, we want a couple of VMs living in the same 192.168.1 network. But, unfortunately, we've got them kind of separated down at the physical level. So the idea being, as we build this up, there are the two VMs that we've provisioned with the cloud management platform through vCenter. But what we also want to do is provision a network for them, and that's where the instructions are going to NSX, which goes down to the controller, which goes into these endpoints and says, okay, what I want you to do is actually, between these termination points, create a tunnel. And to be quite honest, if you were to break it down to its most basic, a lot of NVF, NFV, network function virtualization, is based around the idea of tunneling layer 2 traffic where you want it to be. Okay? Take that broadcast domain traffic, put a UDP header on it, and put a header that we call VXLAN, which is Virtual Extensible LAN, which it describes the encapsulation technology. In this way, we can then say this tunnel has a particular address, absolutely fantastic, and we can start to say these VMs are existing in the same network. So, we'll actually give them IP addresses that match this. Here we go. Great. Now, a big question comes, well, hold on. What happens if I do everyone's favorite piece of technology, which is I vMotion something, I move one of my VMs to another area, or I tear it down and bring it up somewhere else? That can be a bit of a problem. Now, what we're trying to show here, it's the job of the control cluster. The control cluster talks to all the hypervisors. And there are different techniques you can use, etc. But it finds out where are the new virtual machines, where are the old ones, where have the virtual machines moved to, and it acts as a central brain to actually communicate this across the hypervisors. So in this case, absolutely fantastic, we move that particular VM. The new hypervisor that it's sitting on is informed you have a VM which has to be part of this virtual network, this tunnel, as it were, and all that information, all of that intelligence is given to that endpoint, and the tunnel is created. Fantastic. How about there we go, communicate this, you no longer actually have that information. Sorry, that piece of virtual system. Okay, so, sorry, oops, skipped ahead a little bit of myself. So, we then say, well, what about I bring up another VM, VM3, absolutely fantastic. The hypervisor structure itself realizes the new VM's appeared. It informs the control cluster. The control cluster basically knows that I need to update my tunnel endpoint. I need to update the information to the other members of this tunnel, this virtual network. So you think, I'm absolutely happy, I've done this. I've created these tunnels, allow me to create the illusion, as it were, of a single, continuous, local area network broadcast domain. Viewers kind of make the joke that we're not really meant to allow to about Inception, the film about the dream within the dream and all that kind of thing, because we've actually got tired of people comparing it to the Matrix. Anyway, which kind of brings you to another point, but hold on, I've created these virtual networks, that's absolutely fantastic. But in my diagram, I'd actually like to attach this to a VLAN, etc. I would like these virtual systems to talk to the outside world, because they're not a whole load of use if they don't. And that is where we get to another virtual component, which is actually to provide gateway services. So DHCP, access controls, firewalling, dynamic routing, as we mentioned, etc. Something we call an edge device, which, if you take the diagram at the bottom right to be the idea of what we're doing, the rest of the diagram is sort of showing component-wise from NSX how we would actually implement this. So that gives you integration into existing networks. Fine. So all we need to do there is tell the edge device to get out to the real world, this is the gateway you use, and the tunnel can be extended to that perimeter. But one of the real powers here, okay, goes on to corporate network. One of the real powers here is my presentation not actually going forward. Give me a second. There we go. Right. It's always the danger with animations. Excuse me. Yep. That's what we were trying to get. The other idea being that as you do this, if you're creating the networks themselves, how's about you actually start putting in the firewalling? So at each of these ingress-egress points between the virtual networks, you can say, I'm going to have some kind of access control. I'll move on to that, time permitting. Okay. The other question is, well, I've created this cloud, let's call it Cloud 1 or Network 1. How about I want to create something else that from the user's point of view, is absolutely, utterly segmented off. It's another set of networks, another address range or whatever. Again, we can do exactly what we did previously, which is define the network in cloud management and use the controller to push that down. And you can actually run that entire separate networking infrastructure on the same hardware. So it's giving you a lot of flexibility and the idea that you can do this programmatically. Now, once you've got this all set up, one of the ideas is that people are very familiar with provisioning compute. You've maybe used, vCloud Director or equivalent, something like that. And you create a template, and you go click, and 2 minutes later, bang, you have a new set of compute. Once you start doing the software at this layer, you can actually build the software into those templates. So each time you deploy a service, a common model we've seen in academic institutions is around research, researchers, as we call them, research fellows, where they want a set of servers, they want they want an environment set up for them. Well, why not have that all built together as virtual machines with a virtual network with virtual security, little network address translation. They can RDP into this, hit a landing point, and then have access to this environment. And having that actually created as a template is when they go in, one of the definitions of a cloud, it's got a service portal, is they can go, right, I'd like a standard lamp stack, I'd like a workstation to go in, click, and then I'll let somebody else deal with all the nasty things like charging them and working out costs and charge back, show back, or as we like to call it, scare back. So, as far as physical topology goes, this is just a really quick example of how customers have done this. You've got various, in the orange there, you've got the various different networks, you've got a vMotion network, and you've also got the management networks. That's how it would look. You see them plugged into the hypervisors there. From a logical topology, this gives you an idea of how we're doing it with NSX. Now, if anybody, I believe we're giving out copies of these slides. We're not being shy about it, so people can actually sort of look at this and go, hold on, explain that a little bit more. The idea here being as well that this describes from an NSX point of view what we've done. So we've created those 3 different networks, but they're all really sitting on the shared infrastructure. Great. Now, that was the whirlwind tour of what NSX does in 3 stages, really. What is it? Network function virtualization. What's the principle? Control plane and data plane separated. How does it work? A controller is basically looking at the environment, keeping track on where things are, and updates the various routing components. What really, really worries people is how the hell am I going to secure that? Because let's think back to that firewall that we had with 5,000 rules, etc. So, in the context of security, if you've got these virtual networks, that's absolutely brilliant. You've got this virtual network set up and they're all segmented. So really, what it's doing is it's reducing the attack perimeters, it's reducing the attack surface areas, if you will, of each of the networks. Because if somebody gets some kind of malicious code onto one of these systems, well, it's actually only within the context of that particular virtual wire. In addition to that, what we really look at, as you can see there, we're doing that at the perimeter. However, on each of those perimeters, you'll see maybe we've got 3 sets of services. Now we just use orange, green, and blue there. So we've got Web App DB as an example. Another way of doing this from a security context is saying, well, how about I logically describe those guys as groups? So no matter where a web server is, it's a member of a security group called web servers. Same with apps, same with DB. So I can actually start to perform isolation around that, okay? And what we do is we use a distributed firewall. Now, the old way that we used to network had a lot of the problems that physical networks have, which is tromboning and hairpinning, the traffic having to go on really quite circuitous routes. The route that we took is to actually build the firewall into the kernel of all of the hypervisors. There's a couple of reasons for this. Well, the first one was to get line rate through the firewall, because anyone who's got a Linuxy, Unixy background will know that if you want to do networking stuff, you don't do it in user space, which will be a virtual appliance, you do it down in the kernel. We're also looking, like I say, at higher security, because all of that east-west traffic we were talking about, you can actually define the security at the virtual machine. So rather than saying, here's my traffic, it goes through a router, it goes off to a firewall, access control is defined, it's an allow or, it's deny or allow. If it's an allow, it goes somewhere else, more routing. How about I say, I want to make this connection, and the moment that traffic is basically dropped on the wire, you have a firewalling component that you don't even need to route to, that's centrally controlled and orchestrated the same way, that can say, nope, sorry, I don't want you to do that, you're not allowed. Okay, you're not allowed to talk to that particular database server. It actually, not only does it increase security and gets rid of that east-west problem as well, it actually is a more intelligent use of resource, if we dare say, because you're actually only routing the stuff which has already been allowed already been allowed. You're not actually routing traffic, which is subsequently going to hit an access control or a rule that says, I'm not going to allow you to do anything. Okay, so there we go. That's the idea. Gets, optimize traffic flows, gets rid of this idea of the hairpinning, etc., because we make the blocking decision as soon as we hit the VM. We do this through basically logical containers I've mentioned, which say logical container for web servers, for app servers, for DB servers. And within VMware, if you're going to do this physically, you'd be talking about using, 400 machines. It would be effectively 400 separate firewalls, 400 different rule bases. We do this through these containers, going back to the example of Exchange. And we can do this across multiple systems. So actually what you're dealing with is one logical firewall, a much more limited rule set that you don't have to worry about. Now, when it comes to creating security groups, there are multiple ways of doing them. You can do it, as it mentions at the bottom there, the old way, which is MAC sets, IP address sets, etc. When we set this up, our preferred way of doing it is to do it through objects in vSphere, because it means if the system moves, if the system changes IP address, etc., well, we still know it as an object. So no matter where it moves, no matter what happens to it, it still keeps the same, excuse me, effective security, regardless of what the IP address may be. Okay. Another layer that we're trying to throw onto this goes back to the idea of, the zero trust model. How about I start firewalling based on identity? How about I take up Active Directory information, and when somebody comes in and tries to make a connection, instead of saying, this is a big virtual desktop use case, instead of saying based on the source, destination, etc., how about it's based on the user? You're not a database administrator. I'm not going to allow you into the database area. It's a good prevention against insider attack. It's also a good way of ensuring you don't have rogue applications running, and you can actually get these usage reports now based on the user rather than just the visibility to the IP layer, maybe up to the application. Then the joke being it doesn't give you any layer 8 visibility, layer 8 being the biological component of any security system. So, if I was actually going to sort of take this a little bit to its end, here's the idea that we've got the various components, that when you move a system that's just happened there, there's no need for reprogramming. It's taken care of by the infrastructure, by the controller. Workloads moving around. That application-specific security is following the VMs as they move. And I'm always a little bit wary of using that last phrase, but it's one of the buzz phrases we're using at the moment, which is configure and forget. Make the configuration. I saw a few smiles there when I said that. It is one of the ideas we get, that you make that security configuration, but once you've done that, it's basically carryable around the infrastructure by the different systems. Okay? So as a final logical view on that, okay, we give you that idea, the various different tiers, etc. Each one is wrapped up in its own security container. Security containers are, they can be, they can be hierarchical in the sense I can have one for the entire country, I can have one for a city, one for an institution, and one for a department, all nesting within that. Obviously, concepts like which rules take precedence over others are very important, and that is something we have built in. But to be honest, it's a topic all on its own. I'll quite happily talk about it if anyone's interested. I believe I'm here for a while, assuming I don't go to the wrong airport after coming to the wrong university this morning. Yeah. So there we go. So the idea being, we can actually, because we control the infrastructure down to a networking level, we can get into this zero trust model, which works on these bubbles of control and security, rather than, with that access point, rather than this very manual, this very doesn't scale, this very physical approach with that monster rule base in the middle on the firewall. And which kind of gets us to, sorry, I'm aware of the fact that I'm running very much over time, which gets us to the idea here, if you ever wonder why we don't build fortresses anymore, when we defend ourselves physically, it's kind of the same idea. One of the older approaches to network security is very much like a fortress. It's the idea of the different steps that you take through the different access controls, a bit like the walls of a castle. And, I mean, the idea of zero trust as well. Some people look at this and think, yeah, that sounds very much like the next greatest thing that somebody in California came up with. I became aware of this concept probably, I think it was about 12 years ago when I was working for an intrusion prevention organisation, company even, which was starting to introduce the idea, rather than having that hard, crunchy outside and that soft and vulnerable inside, how about we just have a hard, crunchy inside, because we're doing it a slightly different way. Now, that's me at 40-odd minutes. I don't want to tread on anyone else's toes. I suppose, putting up a logo, sorry, I was going to take that one out. It's meant to say thank you, not be a big advertising banner. If anyone's got 80 seconds of questions, or possibly any longer, like I say, I'll be around for another couple of hours. If anybody's got anything that really, there's a lot here that I know people, when they first see, will say, I'm going to query that because I either don't like it, don't believe it, don't trust it, or have a feeling. My job's kind of being beaten up by customers and answering those questions, so I don't know, bring it on, it would be. Anyway, thanks very much for your time, and hopefully that made some kind of sense about what we're talking about. Thanks.
Thank you, Peter. But we do have time for questions.
Sorry.
So,
okay, yep.
Any questions? Then thank you for making the trip over to Sweden. And sorry about the taxis don't understand that KTH is not Stockholm University.
We have a little joke in London that people who live in London often get tripped up when they go to foreign places, exotic places like this, because if you say to a London taxi driver, I need to go to John's house, he probably knows where John's house is.
Exactly.
And occasionally you get in a taxi and end up at Stockholm University instead of KTH. So that's
so sorry about that.
Not to worry.
Och The Cloud och Swedavia har tydligen glömt bort att de skulle komma idag. Det är helt sant. Jag vet inte om det är att Anders har glömt bort att påminna dem eller inte, men de har i alla fall... Jag vet inte var de är någonstans och får inte tag på dem. Så antingen slutar vi här eller så har vi någon diskussion. Jag är mest nyfiken på, jag var ju tvungen att springa ut förut. Hur gick det med den där Edurom? Hur gick den diskussionen? Kom ni fram till någonting? För då var jag tvungen att springa ut och jaga efter Peter. Ja. Thank you, Peter.
It's okay.
Yeah. Give it to me, if you can. It's set confidential. But... Okay, fine. Thank you. Talk to you. You're not in a hurry. But talk. No. Oh. So before everybody leaves, you know where we are going. Ni vet var vi ska någonstans. 6:00, Nationalmuseum. Vad sa du? Hur hittar man dit? Man ber om en taxi som kör en till Stockholms universitet. Hej då.